Excellent. So my name is Carly Stoughgton. I am head of technical marketing here at Apstra. And what I am going to show you guys is a basic overview and refresher on our architecture to make sure we're on the same page in case you guys hadn't seen some of our other NFD sessions. So to start, fundamentally we are a software company. We do automation right now within the data center for a leaf spine topology. And on top of basic automation, we are focused on the day two analytics and the intent-based analytics, which you'll see in a demo later, is a really powerful feature set that we have. So it's far more than just automating the basic configuration of the switches. One important thing to note is we can do that in a multi-vendor environment, which we mentioned in the earlier session. So things like something as complex as EVPN, we can see that automated and harmonious between vendors like Cisco and Arista. All right, so I've got a basic three-stage class here with leaves and spines. So as I mentioned, we are just software. We're not an SDN controller. So it's really essentially AOS, which is an Apstra operating system, is essentially just a virtual machine. So it's not in the control plane, not in the data plane, just a virtual machine. But we're also comprised of a distributed architecture. So on each of these switches, we actually deploy a small agent that's going to live alongside the operating system that's going to be monitoring locally in real time, reporting things back to AOS server, and that's the piece that's actually taking the intent that we specify essentially within AOS server and actualizing that on the leaves and spines. So we'll have an agent that's running on each of the switches. Now, in the case that maybe there's a device that doesn't support the agent, or if we have a few customers for security purposes, they don't want to install an agent or another piece of software alongside the switch operating system, we can run what's called an off-box agent that lives basically as a container within the AOS server VM, and then can communicate with the switch via SSH, netconf, APIs, what have you. But generally, we see them deployed as on-box. Off-box is also an option.
So the off-box, again, that handles all the devices that you can't load AOS onto directly. Then that's your own abstraction layer? It's not Napalm or something else?
So yeah, that's still our own abstraction layer. And it's communicating, though, via traditional ways that you would interact and configure the device.
And in a
traditional legacy.
Legacy, sure.
And in a brownfield deployment, where you do have a lot of legacy devices, you're able to speak to devices, whatever language, whatever method they speak. So it's not just using today's latest, whatever netconf, like you mentioned, things like that. So you can just send SSH or HTTPS, things like that.
It depends. So we still like to rigorously test the devices that we put on our compatibility list. Mm-hmm. So we would prefer to and we need the agent to be able to understand the intricacies of that device from both a hardware and a software perspective. Mm-hmm. And a lot of that has been driven by our customer requests. There's a broad suite of hardware that we support for the data center. But if we have a device that has not been tested and that we haven't certified, that's something that we would work with our customer and a team that we have called the Advanced Solutions Engineering Team, which Rags heads up, that you'll be hearing from later, that we'd work hand in hand to make sure that device is supported and tested.
So, Carly, you said it's not in the control plane, it's not in the data plane,
right.
But basically, a server sending the configuration down to the switches, your intent, right?
Right. Yep. All right.
Not in the control plane, but
like
with the whole continual validation, there's still continual communication with devices to enforce policy, right? Check on deviation from configuration, whatever goal.
Yes, we're still validating that the intent matches the operational state.
Right.
But if for some reason the AOS server VM or something was to go down, that has no effect on the data and control plane. A little bit of a departure from traditional
The
SDN.
validation plane. There you go. That's good. You better market that and copyright it quick.
All right, you guys ready for the other side?
Yes.
Maybe it's the intent plane.
The intent plane. That's good.
Here we go.
Yeah. Surprise.
Do the Vanna White. So I know this looks like a lot, and we've talked about pieces of this before, but really this is, I actually wrote this out the first week that I joined Apstra. I wanted to understand kind of the object model and the layers of abstraction that we have and how that fits into actually modeling a data center. So I know it's a lot, but it's actually not that complex. And again, I could spend probably 2 hours on this talking about the intricacies, but we're just doing a level set here just to make sure we understand the basics. And you will see some more pieces of this in the demos later on. Okay, first thing that we do is we have this concept of these kind of reusable building blocks that we use to model a data center. And the first piece of that is really what we call a logical device. And this is an abstracted, simple description of my intent. So let's take a leaf, for example, leaf switch. Regardless of the vendor that I end up using, there's a basic way I can describe my requirements, right? I need maybe 8 ports of 25 gig. I need 4 ports of 100 gig. And I also specify what can connect to these ports. So for example, on these guys, I might say, on these 8 ports, I can connect servers, or I can connect, say, peer links in the case of MLAG or VPC. I can also specify the intent for the roles on these ports. Things like these should be connected to spine switches, or they could be used to connect to external routers to get out to my WAN and internet. So just high-level intent. Again, no vendors, no hardware-specific lingo. Just these are my base-level requirements. The next building block that we really map to is you create a rack. So I take that, in this example, my leaf, and say, okay, maybe I want, in this potential rack, I want there to be 2 leaves as my TORs. And then I specify things like the servers, which is also modeled as a logical device, so which would be like 1 by 10 gig or 2 by 10 gig or 2 by 25 gig for the servers. And then I specify things like the number of uplinks for each server, the number of links up to the spine switches, number of leaves per rack. So again, we're not saying any vendor specifics or hardware specifics, just these are my abstracted requirements. That's also where I'd specify whether these are going to be traditional layer 2 servers, or if I'm doing something fancy like routing on the host and actually running a routing stack like free range routing on the host, whether that's going to be L3 down there. So the next piece that I take kind of these building blocks and again start assembling them together is what we call a template. So I think of this essentially as a rubber stamp. So it's a repeatable unit that I can reuse. And this is really where I take these logical devices and the racks and start putting them together in a hypothetical data center. So I would specify, I have these spines with these requirements. I have instances of these rack types, and I could mix and match which racks that I have in here. But essentially, this is one instance of this rack that I modeled. That's also where I can specify, what the routing policy is, whether or not I'm using EVPN or just traditional static VXLAN, IPv4, IPv6, and where I'm pointing to external links and how that's connected to a router. So that template's essentially the rubber stamp. The actual data center and the living, breathing entity is what we call a blueprint. So we can think of that kind of like the print that comes out of the rubber stamp. So I use the template to instantiate one of the blueprints, and after that, the blueprint is its own living, breathing object. So in the blueprint, again, I will have pointed to that template. And then within the blueprint, this is where I'm actually creating my virtual networks, my VLANs, VXLANs that need to exist within the network, security zones, which we render as a VRF. New feature that we've added, which is really exciting for us, is VMware integration. So we can actually connect to vCenter via their APIs and look at the inventory of the virtual machines. We can look at where those VMs are hosted, which hypervisors. We can also look at things like the distributed virtual port groups that are present from the virtual networking. So we can correlate from a physical and virtual perspective what we have. And that's also where we're going to be doing, all of our day two operations. So this, initial automation is one piece, but the power of what we do really is in our intent-based analytics, continually validating in real time that the intent matches the operational state, and making sure that we're continuously monitoring and validating in real time from one place that everything, our intent, is being met. Other pieces that tie into this. So far we haven't talked about any specific vendors. The piece where we actually specify which vendors we're using and the actual hardware that's being used, we'll have a pool of managed devices that we can, from AOS server, deploy agents to, monitor the hardware and software capabilities. And then we have device profiles, which represents the actual physical device itself. Right? This is the hardware capabilities, the CPU, the memory, the operating system that it runs, the port capabilities, possible transformations that exist on the switch. And the key piece here is the interface maps. So the interface maps are what's actually tying together this abstraction of intent and abstraction of requirements to an actual device that meets that intent. So the interface map will tell me, okay, I'm going to be using this actual device. I'm going to be using the ports at these speeds, whether that consists of a breakout cable or not. This is the actual glue between the physical device and the logical device that I modeled. So at that point, we're actually saying, okay, it's a Cisco switch, or it's Dell, or it's Arista, and what operating system.
Okay. Let's say I am doing layer 3 between leaf and spine. Okay. I can run BGP, I can run any link state routing protocol, or maybe I am running Rift routing in FAT3. So I think it's routing protocol agnostic, right? So what Apstra is doing for that?
So we have the reference architecture that we have right now that's been the best fit, and what we see the majority of the industry doing is to run a set version of routing protocols and overlays and underlays. So we're using BGP for the underlays and overlays, and we can use VXLAN and then optionally EVPN. And we have that set in the way that we found is the best design for the layer 3 class topology. So right now, it's BGP. That's our initial reference architecture. That's not to say other things aren't possible, but that's what we found has been vetted out the most.
But let's say Rift now is getting popular, and later on, if one of the customer is running or wants to run Rift, so in that case, AOS server needs to understand, right, Rift language.
Yeah, so that's definitely something we could look at for a different reference architecture. Essentially, AOS is the platform, and the data center layer 3 class topology is our initial architecture on top of that platform, but it's certainly extensible for other options. Okay. So that's something we could, if we had a customer that was interested in that, we could work with them, and again with the ASC team to figure out, is this another architecture that we want to offer on top? Yep.
Carly, what about multi-site? Are you able to look at other data centers on enterprise networks now? How does it work from your AOS server?
So what we've seen people do so far is they would model each site as a different blueprint. Okay. So I could have an instance of AOS server, and then I could have, say, east site and west site would each be different blueprints.
And let's say as a service, EVPN, they are running between multiple data centers. So I think you can support it. Site EVPN? Is it
We're looking at that. Right now, we wouldn't be doing the inter-site connectivity. It would be independently managed blueprints. But that's something we're actively looking into.
Thank you.
Can you explain your concept of what a reference architecture is? That's probably a question.
Sure. So we have a really funny analogy we use. We think of AOS server as basically a gaming system. Like the one we use in our slides is an Atari, but that's a little old for me. So I'll say a Super Nintendo. Like a Super Nintendo is AOS as a platform, and then each reference architecture is like a gaming cartridge. So right now, our main gaming cartridge is the data center, L3 three-stage Kloss. But since we built the platform in the way that we did, it's very easy to build other games to move on top of that. It's not like I need to go buy a PlayStation and re-architect the whole thing.
Does that change the dynamic of how quickly you can build out a data center? And you know what I mean? If you're going into a custom situation like that. I mean, the key is having the reference architecture, your golden image to reference and validate against already done. Right?
Yeah, so in terms of just building out a data center, you'll see in the next presentation that's a matter of minutes. But if it's one that deviates from our reference architecture, that's again where we involve RAG's ASE team and evaluate doing that. But we've definitely gone outside of that initial reference architecture.
But the constant process of validation, day 2 and on, is always going to use that reference architecture, right? So that is a key component, whether it's custom or something that's baked in already.
So if we're looking at a new reference architecture, we also are bringing in the day 2 piece as well. So we're looking at the analytics that are relevant to that architecture.
Data and all that kind of stuff that's coming in. And
And that's also, that's something we'll proactively look at. And as we'll see in a later presentation, the intent-based analytics is totally extensible. So if we had someone that had a different architecture and there was something that we weren't personally monitoring, but they wanted to look at, they could write that themselves today. So.
Okay.
All right, we're coming up on time a little bit, so I want to make sure that I covered everything. So we talked about the glue and the interface maps. The last piece was the resources. So these are essentially the identities that give this blueprint life. So we have pools that you can create, things like autonomous system numbers, IP address pools for things like loopbacks and VNIs. Also, the resources could include things like the external routers that we're connecting to on the WAN or the internet.
So intent for the underlay as well as overlays doing.
Yes.
VNIs, so autonomous system numbers, since you said BGP as a reference architecture. So
All of it.
Cool.
Yeah. And as you'll see in the next demo, I mean, if you're looking at EVPN configuration, it's long.
Yes.
So we make that pretty easy. All right. Questions?
So far.
Again, these are just the building blocks, and and we'll see as in the next presentation, creating this and using these only takes a few minutes. It's really not that involved of a process, but good to just understand the relationships between the two.
Just one question on vSphere integration. That's any version, or there is a compatibility matrix that will show you which ones you can grab the inventory?
Yeah, we always have a compatibility list that shows which versions we've actually tested either in our labs or with a customer in their deployments.
How many, do you have like a quantity, how many you can do? Like if a cluster has like, 5 or vCenters, can you grab all of those?
We can manage, multiple vCenters within a single topology. I'm not sure if we have a tested maximum on the number of vCenters, but you can definitely do more than one.
Blueprint, interface map, all the device profiling is just done on the AOS server?
Yes. Yep. AOS server GUI, and of course we have multiple APIs that you could use if you prefer that. Yeah, all available through the GUI. We have a lot of defaults that ship out of the box, so likely you won't actually have to create any of these. You can just reference them and use them.
And I have a question. here you've pretty much outlined the data center use case. Does Apstra have any plans to move into any other verticals? For instance, I could see how this could be applied to, say, a service provider network where there's lots of protocols, like various L2 VPN configurations and RSVP, TE, and stuff like that
Yeah.
require a lot of manual configuration, where I could see something like this being beneficial.
Yeah, absolutely. So as I mentioned, and as Mike mentioned in his last presentation, we absolutely, this is where we needed to start, being a startup. But yeah, this is definitely applicable in way more spaces than just the data center.